So in this video, we're going to go through the order analyzer tool that I've created in Python, which will automatically analyze customers' order data and give us very useful information and graphs that we need to design new warehousing systems. So before we get started, let's take a look at some example data that we'll use to analyze. So here I have some example warehousing order data that we'll use in this analysis. This example order data is split into two files. This one is called ecom and there's another one called retail. And the reason for that is each one of these is 750,000 or 770,000 lines each. In Excel, you can get up to a maximum of 1 million lines per file. So combined together, we're looking at around 1.5 million lines of warehousing order data. And the order data that I'm going to use here is, it has a few columns. So the first one is the date column, which is very typical of our order data. The next one is our order number. The one after that is our SKU number, and after that we have the quantity sold column. In this data file we also have the length, width and height of the eaches, so that's each of these SKUs on each of the order lines. It also gives us the total volume of that order line, which in this case in our analysis we don't need this because we can do our own volume analysis. It also provides us with the customer type as well. So as I mentioned before, this one is the ecom file, so it's B2C customer type, and in the other file, which is just as big, it's B2B, which is retail customers. So this is some of the data that we need to run the code. So let's get the code started. So let's run the tool. So what I'll do is I'll load up the Python code. So the first thing that happens when I load up the code is that it starts to import the Excel files that we looked at before. So it's opening up the ecom file and it'll open up the retail file and it will combine them together because each one of those files is over 750,000 lines. So together it's about 1.5 million lines of order data. So now what it's done is it's combined them together into one large data set and it's clearly listed the column names here. So we have date, order number, SKU, quantity, each length, each width, each height, the line volume and the customer type, and the software is going to ask us for the relevant information that it needs to run. So the first bit of information that it wants is to input the name of the date column. So we know that the date column in our data is actually called date. So I'm going to type that in. Then it's going to ask us for the customer type column. So our customer type column is actually in this case called customer type. Then it's going to ask us for the order line column or order number column. So I'm going to type that in. Then it's going to ask us for the quantity sold column, which in our case is quantity, QTY. And then it's going to ask us for the SKU column, which we're going to put in. Then it's going to ask us for the number of working hours in our warehouse from 1 to 24. So in this case, I'm just going to put in 8. So we're going to assume our warehouse runs on one shift. And then the software is going to start analyzing all the data and then generating the graph. So this is going to take a few minutes. I'm going to fast forward the video to when the processing is complete. So the first bit of information that this code gives us after it's done processing is a quick health check. Visual health check of the data by generating a stacked Pareto graph of all the individual dates. So we can see here that the data looks healthy except for 1, 2, 3 days here where the data doesn't look that well, but the first initial impression is that the data looks healthy. So I'll close that. It generates for us the orders total by week and customer type graph. So it automatically categorizes the days to week numbers. So we have week 17 all the way to week 34. And it tells us in red what our peak week is. So it tells us our first, second and peak weeks, all nicely visualized here. If I close this graph, The second graph generated is a similar format, but now it's showing us the order lines total by week and customer type. So it's showing us what our peak week is in terms of order lines, first, second, and third, again, arranged by week numbers rather than days. If I close this, the third graph generated shows us the items total by week, and again in a similar format. And if you haven't noticed already, it also stacks the B2B and B2C orders as well. So it puts them all together so you can see how that split looks like. So I'll close this. Other than that, it also generates for us a full order profile analysis in an Excel format. So I've just opened this up. And you can see here it's color coded based on, so what I've done is I've programmed it to color code based on the individual days. So it gives us a full order profile analysis based on the days and customer types, so B2B, B2C, and combined. So it gives us all the relevant bits of information that we need to analyze our data even further. So all this is done automatically in the code. In this video, I won't go through each of these columns individually because there's a lot of information here, which does save us a lot of time processing this manually. And it also tells us our hourly throughputs and hourly information as well based on that 8-hour working shift that we put in earlier. So I'll close this. It also generates another Excel file that tells us how it splits up the week numbers. So if we need to, if I could just expand this out. So we have week 17 all the way up to week, was it 34? And it's put each of the days into the right category as well. So if we wanted to kind of reference that on which days that is, then we can see here as well. And this is just the first part of the code. So there's a lot more to go through. So let's carry on with our Python code. So the next part is we want to do a full Pareto analysis on the data. The first thing is listed here is the categories that we're using for our A to D movers. So we've assumed here that our AA movers, which are the super fast movers, are from 0 to 5% of the top SKU. Then A movers are 5 to 15, B movers are 15 to 30, C movers are 30 to 50, and D movers are 50 to 100. We can change this category if we want to put a different parameter in, but I want to keep it as the standard. So what it asks me is, do you want to adjust the movers category? Yes or no. I don't want to adjust it, so I press type in N and press enter. And now what it's going to do is it's going to, based on the peak week that was analyzed, so those 7 days of the peak week, it's going to show us a detailed Pareto analysis. So in this Pareto graph, we can see our categorization of AA, A, B, C, and D movers. And it's telling us that our AA movers, so our top 5% of the SKU, make up 42.2% of all the sales. Our A movers, which are the 5 to 15, make up 24.3% of all the sales. So combined AA and A make up 64.5% of our total sales. And then B 17.5, C 10.9, and D 7.1. So this is very useful information. Detailed Pareto analysis done automatically from the data based on the peak week, those 7 days that the software picks up. It also shows us our standard 80-20 rule Pareto. So if we want to use that as well, we can see that 80% of the total, someone's calling me, 80% of the total sales is actually done or carried out by 27.7% of the total SKUs. So that's quite useful. And it also generates a blank Pareto as well if you want to use it in any kind of presentation or further analysis. So I'll close that. It also generates should generate, and there we go, an XYZ analysis automatically. So this is telling us from AAX to DZ how those XYZ analysis looks like. So we can see here we have AAX, AAY, AAZ, all the way to DX, DY, DZ. So in terms of SKU, lines, and items, it automatically categorizes it here for us. And if I close this, it also shows us the XYZ as a percentage as well. So if we want to use it as a percentage, it's clearly shown here. In this video, I'm not going to go over the details of what XYZ analysis is or what Pareto analysis is. I'm just simply demonstrating the power of the tool. So if I close this, another graph is generated. So this is another, probably better in this view, this is another very useful graph. So it tells us the category of our AA to D movers in terms of a pie chart. So that's what we looked at earlier. So the split is 5% is dedicated of our SKU is dedicated to AA, 10 for A, and so on. And this other pie chart here shows us the percentage of sales per category. So it's telling us that our AA movers, which is our 5% of SKU, is actually responsible for 40.2% of the total sales. Our A movers, which are 10% of the total SKU, is responsible for 24.3%. So we can see clearly how that split is done. This bar chart here tells us the number of SKU per category, so that in our peak week, there was a total of 2,408 SKUs hit, and it's telling us that our AA movers make up 120 SKU, our A movers are 241, B 361, and so on. So this is a good visualization to see how many SKUs our AA movers are made up of. The other graph here on the right hand side, this tells us a total items sold per category. So there's a total of 215,447 items sold on that peak week. And that's telling us that our AA category actually sold 86,266 items. Our A movers sold 52,563. Our B movers sold 37,000, and so on. So you can see it's quite a good pattern being shown here. It's telling us that our AA movers, which make up only 5% of the total SKU, are made up of 120 SKU, but they're responsible for 40.2% of all the total sales, which is 86,266. So this part of the module does the full Pareto analysis, and it also before I go to the next section, it also spits out a full Excel file which summarizes the Pareto analysis. So if I load this up, it actually tells us what that Pareto analysis is in terms of Excel. So if we want to do any further analysis, we can do with this Excel file, and it tells us all the information we need here. So this is quite useful if you want to further analyze the Excel file to know what your AX, AAY, AX categories are, and so are your fast movers, your slow movers, and which SKU they are. You have a full Excel file generated. So now let's move on to the next section. Now the next graph that it's generating is for the synergy of SIO items. So if we're designing a new ASRS system, if we're sending single item orders out, there's typically a lot of synergy when it comes to single item orders, and we don't need to send out so many of the same totes again and again to the pickers if there's synergy. So this graph here is telling us how much synergy there is in our SIO orders. So it's telling us the unique SKU and the non-unique SKU. And this is showing us the split here. So in this graph, it's telling us that the synergy between our SIO orders, so single item orders, there's 47.3% synergy in total, and the average calculated synergy is 52.7%. This value is extremely useful when it comes to calculating the number of tote retrievals for our ASRS system for this order data. For example, if we have 100 single item order lines per hour, and there's 47.3% synergy in the single item orders, then we take 100 and we times it by 52.7, and that gives us 53, if we round it up to 53 tote retrievals per hour for single item orders, rather than sending out 100. So it gives us this useful information as well, and it does it for B2B, B2C, and combined. I'm just quickly closing these because I've already talked you through it. And it also generates an Excel file with the synergy analysis listed here. So if you want to do any further analysis, this Excel file is available to you as well. So as you can see, it's generating all these graphs and Excel files as we go through the software. So let's go back to our tool. We're not finished yet. The next thing it's asking us is if we want to sort based on day or week, and this is to calculate the system utilization. So here I'm going to type in week for the purpose of this demonstration. I press enter, and now it's listed It's shown our graph in terms of the number of total items sold per week, and it's telling us the utilization level. So if we design our new ASRS system based on the peak week, which in this case in terms of items sold is week 33 at 299,000 items, we only get an average of 70.6% system utilization. That's not a good figure if you're designing an ASRS system. You want to get a good healthy figure of 85% system utilization year on throughout the year. So this is telling me that if I design my ASRS or my new picking system to pick to the peak week value, I only get 70.6% average utilization throughout the year, which means 30% of my system throughout the year is underutilized or not utilized. This is also showing us that if we design a system that's is designed to handle the average of the year, we get 93.8% utilization. So this line that you can see here is the average of the items sold throughout the year. 93.8% utilization is also not a good or healthy figure either, which means as you can see here, throughout a lot of the weeks in the year, we might have to move a lot of the picking operation to manual pick as well as automatic to make up for the difference. So what we want to do is we want to aim for 85% utilization, and how we can do that is if I close this, we want to put a figure in here. So it's asking us to put a number of total items. I think if I type in 240,000, let's see what that shows us. It will generate a graph. So I typed in 240,000, which is just here. That's telling us if we do 240,000 items a week, on average we get 86.18% utilization. So we can actually go a little bit lower than this, or we can go higher. So I can see here that 1, 2, 3, 4 weeks in a year we have to move some of our operation to a manual pick if we want to get 86% utilization. Now that could be okay. I can go a little bit over and only push 2 of the weeks to manual processing. So I would say let's do this for 245,000 items a week. So if I close this, it's asking if I'm happy with the results. I'm going to say no, and I'm going to try again. So what was that? 245,000. Yeah, so 245,000, we get 84.7% utilization, so that rounds up to 85%, so we're spot on to the utilization level that we need. And for only 2 weeks in the year, so that's week 30 and week 33, we only move some of our operation or some of our SKU to a manual pick area to make up for the to make up for the lack of ASRS. What's the word here? To make up for the lack of abilities that we have in our new picking system. So if I close this, are you happy with the results? Yes. And then what that's doing is it also generates, it should generate an Excel file here. Actually, no, let it process. So what it's going to do now is it's going to process the data. So now it's processed that data and it gives us a SKU balancing report. So if I open this up, so we wanted to achieve 85% utilization. What this is telling us in the report here is, if I could expand this out. So in order to achieve 85% utilization on weeks 30, if I can highlight here, and on weeks 33, we need to move 2 of our top SKU and 1 of our top SKU to a manual pick area. So that's a total of 16,156 and 75,000 items. So these are actually very popular SKU. We move them to a manual area and we can achieve 85% utilization. And in this other tab here, it actually tells us the SKU numbers or the SKU names that we need to shift to our manual area to achieve that utilization level. So the next part of the code is if we want to use peak week dates. I know what this is. So this one is for parcel size analysis. So the next part of the code we want to generate, or we want to calculate how many parcels we will generate in a given week, in our peak week, based on predetermined parcel sizes. So in the code, as an example, what I've done is I've put in 6 examples of parcel sizes from B1 to B6, ranging from small to large. So I've programmed it to be B1, B2, B3, B4, B5, and B6 size parcels. You can put in any parcel size, or as how many different parcel sizes you have in your warehouse. So you might have a large range or a small range, and the code will calculate for you how many of each type of parcel you will generate for your orders in that peak week. So that's what the next section will do. So I'll use the peak week values. Yes, we can also input our own manual dates if we want to, but in this case I'm using peak week. You could put peak day. And then it's asking for information from our original Excel file in terms of length, width, and height to do that calculation. So from the Excel file, it lists the columns that we had. Again, just in case we forgot, we had date, order number, SKU, quantity, each length, each width, each height, line volume, and customer type. So it's asking us to input the name of the length column. So the length column in our data set is called each length. So I'm going to type that in, each underline length. Then it's asking us for the width column. So each width, that's what our column is called in our data. And finally is asking us for the height column. So that's each height. And it's asking us if it wants us to replace 0 values inside the data. So some of the data that we receive might have bad values. So it might have a length and a width for a SKU, but it might be missing a height. It might be missing some information. We can ask to ignore it and just use the information that we have. Or we can use some clever analysis that this tool does, where it replaces the bad values or the 0 values that we don't have with some averages and medians. So I'm going to say yes, replace the bad values with a good estimate if we do have any bad values in our data. Actually, no, I'll put in no, just to see if we do have any bad values, because that'll show up as well. So actually I'm going to change that to no. So now it's going to start processing our data to calculate how many parcels are going to be generated at peak week and what those parcel sizes and the splits are going to be. This information will be very useful when we're doing sort analysis, or we want to know exactly how many parcel types of each we're going to order at our packing stations. It gives us a more detailed insight into what the packing operators need to do and what kind of size parcels are they going to be generating for the orders. So we'll just let this process and we'll come back once it's processed. So now that that's done processing, it's going to generate this graph for us. So if I could full screen this graph. So this graph here is showing us our parcel splits, B1, B2, B3, B4, B5, B6, and also oversized and bad. So we can see here it splits it up between single item orders and multi-item orders. So the light blue represents SIOs, single item orders, and MIO is multi-item orders in red. And it's telling us that 33.4% of our orders at peak week, which is a total of 24,257 orders, is dedicated to B1 parcel type. So that's 8,103 parcels are going to be generated at B1. B2 parcel size is going to be 37.2%. B3 is 7.2%, B4 is 5.5, B5 is 12.8, B6 is 0.2, and we're going to have 3.8% of our parcels that are going to be oversized, so they won't fit in to either of these categories, so they may have to be split between different boxes. And it's telling us that in our data set here, we didn't have any bad values. If we had orders, or if we had SKU information that was missing a length or a width or a height, or it was showing up as 0, it would show here as a bad value. But in this case, in this data set, we don't have any bad values. The graph on the right is showing us the split between single item orders and multi-item orders for each of the parcel types. So here we can see that for B1, the single item orders make up roughly 50% of all the B1 type parcels, and the multi-item orders make up the rest. For B2, we can see that it's mainly multi-item orders. And B6 here, the larger parcel type, we don't have any single item orders that actually need a B6 or a larger size box. Is generally the multi-item orders. And for oversized, we can see here there's actually, which is quite unusual, there's a small percentage of SIOs that don't fit in any of these categories. They must be very large items, and multi-item orders make up most of that percentage. So this is very useful if we need to kind of allocate different parcel sizes to our packing stations, or if we want to calculate the sorter size downstream, or if we want to basically estimate the shipping costs for our orders as well. So this is also calculated from the data automatically. And if I close this, it also generates an Excel file for us. And in this Excel file, it gives us the full rundown for SIO orders and MIO orders and the different parcel types needed. So here it's just giving us more detailed information based on that graph that we looked at. And there's an overall tab here as well for both SIOs and MIOs with those splits here. So if you want to do any further analysis or want to look into see which orders or which product types are generating the larger parcels, you can from this Excel file. So this concludes the order analyzer tool that I've been working on. So just to recap, from very simple order data, so date, order number, SKU, quantity, and simple each length and height and width information, as we can see here, we generated all this useful information, charts and Excel files, and a full order profile analysis done automatically in this live run. This code that I'm working on is modular, so I plan to expand it, put more features. I want to put a pick face analyzer into there as well. So if we want to calculate the size of our pick face based on an hour, a day, or a week, we can do automatically as well. And I want to put in a nice graphical user interface in the future versions to make it a bit more user friendly. So I hope you like this video, and any feedback will be appreciated. Thank you.